Objective number 4. Find the sum of geometric series. If we have R is in the between of -1 and 1, then we can find the infinite geometry series. Is formula is A1 divided by 1 minus R. We need to know the first term A1 and the R, the common ratio. We notice the difference between this formula and the formula in objective number 3 is that the formula for the geometric, when we want to add, look at the example 7, the number that just keep going on and non-stop, then we can able to add them up and we can find the final answer for this. When in objective number 3, we have the limited of the term. This is continue forever if we want. However, we want to know specific number, how many number that we want to add them. Is it 10 of them? Is it 8 of them? Or is it 70 terms together? But in objective number 4, this is go forever. And we have the formula to add all of the numbers until they go into the very far away. Example number 7. We first identify this is the geometric. The problem already tells us that, but we need to double check. We see that from one term to the other, we multiply by 1/2. Okay, so to find the common ratio with double check, you pick A1 and A2, then you do A2 divide A1, and you got 2/4. So that's why we get 1/2. Or you pick A3 and A2, then you do A3 divide A2, and 1/2. So we also get 1/2. The ratio is 1/2. Now let's use the formula. The formula is the sum of geometric series A1 R to the n minus 1. This is the general formula for the geometric series. From n from 1 to infinity is equal to A1 1 minus R. You only need to pay attention to this part and just plug in the number for that part, the yellow part, okay? Now you plug in A1 is the first term 4 and 1 minus 1/2 for R. So we got 4 divided by 0.5. And 4 divided by 0.5 is 8. Example number 8, express 0.1 with the bar on the top as a fraction in lowest terms. 0.1 with the bar on the top, this is mean 0.1111111. So the one just keep repeat and go forever. This is mean 0.1 plus 0.01 plus 0.001 plus 0.0001 and so on. This is the geometric because from one term to the other, you will multiply by 0.1. And you will multiply by 0.1. So your R is between -1 and 1. The condition for this is geometry, but the R have to be between -1 and 1. We go back to example number 7. The R is 1/2 and it is between -1 and 1. So that's why we can able to find the finite sum. The finite sum for this is that n from 1 to infinity of A1 R to the n minus 1 is equal to A1 over 1 minus R. A1 is 0.1 and 1 minus r is 1 minus 0.1. So 0.1 on the top, 1 minus 0.1 in the bottom is 0.9. If I multiply top and bottom by 10, then I will get 1 over 9. So if you use calculator, you do 1 divided by 9, you will get 0.111111.